So we have a triangle. I remember it was 5, 3, and 4. So it's not a right triangle, so we can't use half base times height to get the area. We want the area. What that means, we want to know the shaded region, which is this whole thing. We want to know what it is, right? So I'm shading for you. See? Okay. So we want to know what that is. To do that with a non-right triangle, we need a formula, and that formula is called Heron's formula. I think man, if you go online, look for the proof of this formula, how the person made it. I think they have sometimes a 2-part series. And I remember in the university when they showed this formula to me, it took more than 1 day for them to complete the proof of this, like how it was made. Okay, so Heron's formula. But I encourage you, look up how this formula was derived. And I think I will get a refresher on it sometime today on how this came about. All right. I mean, those guys in the past, they didn't really have like a lot of distractions, but they use their time wisely. So here we go. The semi-perimeter is equal to A plus, oh boy, let me fix that. On my end, my computer is kind of glitching. So if you see me write something really strange, it's my screen is actually jumping. B, this is the formula over 2. And the formula for the area, as I remember it, it's always good to write out the formulas first. S minus A. This means everything will be multiplied together. S minus B. And you know, when this guy found this formula, he probably jumped up and down. It's like, whoa, look what I have found. And now people are still using it like thousands of years later. Even though we have all this technology, we still use this formula. It's crazy. All right, so now let's apply. We know what, let's say this is, let's call this A, B, and C. Now, what does that mean? That means this is the angle B. Well, let's start here. This is the angle A, this is the angle B, and this is the angle C. Notice it gets a capital letter. All the angles get capital letters, but the sides get a corresponding small letter. So if this is the angle A, then this would be the side A, but we'll use a little a to represent that, okay? If this is the angle B, then we'll use a small b to represent the side AC, okay? And if this is the angle C, then we'll use a small letter C to represent the side AB. So that's how triangles work, how you interpret them, okay? And you'll be doing that when you all the way up to Fort Foreman forever. This is the way to do it, okay? So now let's go ahead and solve it. Let's find our semi-perimeter. A is 3 plus 5 plus 4. If I had planned this out, I would have made it look like 3, 4, 5. Anyways, and put the 2 there. And so we have 3 plus 5 is 8 plus 4 is 12 over 2. And this gives me 6. Okay. Now, let's apply this to the formula. Let's find our A. Now, let's make it even more accurate, like more realistic, and not just put 5, but let's put a unit of measurement with each one. Okay. So I want you to see what actually happens when you use units of measurement. So we'll put that across there. 6, right? S, replace the S with 6. 6 minus 3. 6 minus, what's B? B is 5. And 6. Oh, look at what I'm forgetting. Make it write this correctly, guys. Okay, 6 minus, well, the semi-perimeter is actually 6 centimeters. Okay, there we go. 6 centimeters. All right, let's try again. 6 centimeters. So you have to be willing sometimes to erase your work and do it over. It's just gotta be diligent, guys, okay? Don't look for the shortcut. With math, you have to go step by step by step by step. Sometimes it feels tiring, but that's how you get to your answer. Okay, the 5, right? And finally, 6 centimeters minus 4 centimeters. And now it fills up the space nicely. I was kind of disappointed that everything was going to be over here, and I left, and this long thing is, you know, this would be left hanging like out there. But now it looks good. Okay, now it's time to solve it. So let's go ahead. Now you're definitely getting points for everything you're doing right up to this point, even putting in your units if the problem involves units. Okay, so I'm putting back my 6 centimeters. That doesn't move. Nothing, no operation is happening there. Now we have 6 minus 3 centimeters. That gives me 3 centimeters. 6 minus 5 centimeters, that gives me 1 centimeter. And 6 minus 4 gives me 2 centimeters. I'm already seeing how nice this problem is. I see why they set it up this way. Okay, now we're almost there. Look at this. If you don't need to focus on these, but automatically you can see that 3 times 1 is 3 still, right? And 3 times 2 is 6, and 6 times 6 is 36. I mean, man, I like this problem. But what I want you to notice as well is what happens to these centimeters, 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 centimeters. So if you have a centimeter, we know that's just centimeter. But if we have centimeter times centimeter, you get what, guys? What does this give you?
Squared centimeter.
You get this, centimeter square. And if you have cm times cm times cm, what will that give you, guys?
Centimeter to the power of 3.
Very good. And so we know, oops, there. Let me just fix that. Okay, so we're here now. We don't see centimeter times centimeter. We don't see centimeter times centimeter times centimeter. We see centimeter times centimeter times centimeter times centimeter. So what will this be? Centimeter to the power,
4.
yes, 4. Now imagine, we can't imagine what that looks like, right? We can't see 4-dimensional stuff, right? This here would be a square. This would be like a cube. Okay, centimeter, centimeter, centimeter. And each dimension, each width, length, and height they're all at right angles to each other. Just like this width and length is at a right angle to each other. But we can't figure out where the next right angle is to go to a higher dimension like 3 to the power 4. So we can't figure that out in math. Did you guys know that? Mathematicians don't know how to figure that out. We can't figure that out. How about you guys? You guys, future mathematicians, maybe you'll get it, right? Maybe you'll be able to figure out where to put that next line so that it's at a right angle and it leads to to a 4th dimension. All right, so I'll leave that for you guys. So here we go. Now, square root, I want you to see this. If I had centimeter to the 2nd power and I was square rooting that, it would half the 2. I would just end up with centimeter to the power 1. See that? When we don't write to the power 1, right? We know not to do that. But that's what would be happening if I square rooted centimeter square. I would just end up with centimeter. So what do you think will happen when I square root centimeter to the power 4? What will I end up with?
Centimeter to the power of 2.
Very good. You got it. You'll end up with this, which is what we want. We want an area. Okay. What's the square root of 36?
6.
Yes. And the square root of centimeter to the power 4 is?
Centimeter square.
Very good. That's your answer.